Hi, everybody. If this is your first time joining office hours, my name is Nicholas. I'm a data scientist at the Data Incubator, and we partner with WorldQuant University to bring you this course in machine learning. So, the reason I'm here is I'm here to answer your questions as you work through the course. And I already see a few familiar faces here in the chat. I see Tulalupe is here. Hello, hello. How are you? Nana is also here. Hello, Nana. I hope everyone is doing well. I see people joining up in the chat room. Very excited to chat with you all today and to look at some machine learning problems. Corazon is here. Good to see you, Corazon. Enzo is also here. Hello, hello, Enzo. Welcome, welcome. Tulalupe says they're doing fine. That's great to hear. Good news. I hope everyone else is doing well too. So, everybody, what can I do today to help you? What would you like to look at today during office hours that's going to help you progress through the course? Enzo says they're having some trouble with time execution. Enzo, what do you mean when you say time execution? Is it like getting everything done in the course, or are there certain lines of code that are taking too long to run? What do you mean by time execution? Well, Tolupe is dealing with the NLP questions, and they're having some trouble with a kernel dying every time. We can definitely look at the NLP mini project. That would be a fun way to start. What about the rest of you? What other topics would you like to see today? Okay, so Enzo's having a similar problem to Tolupe where some of the code is taking too long. Enzo, am I right that you're also talking about NLP? So Nana has what they say might be a strange question, and they want to know if they have to use Spacey for the mini project. For example, can question 1 be improved using spaCy? Well, why don't we start with question 1 and we will see. So the first thing that I'm going to do, I'm going to open up, I'm going to share my screen with you guys. So I'm here in the Machine Learning Mini Projects folder, and from there I'll click on NLP. I'll make the text a little bit bigger. Oop, that was the wrong window. Hold on. There we go. Okay. So let me just run a few of these cells so that everything is ready to go. Okay, let's start with Nana's question about question 1, which are there ways in which we can use spaCy to help with the mini project? So my question is for Nana, what are some ways in which you think spaCy might be useful here? I see Mika has joined us. Welcome, Mika. Glad you've made it. Nana says this is just a hypothetical. Well, I'm seeing some good ideas in the chat. And I think what we need to do for question 1 is to just review what it is we're trying to do in our pipeline. So let's see here. What we want to do is we start in our pipeline with our key selector. And from there, we take each review. So each unit here, each text is going to be, each document is going to be an entire review. And then, so we use our count vectorizer to put it into a vector space, to put it into a format that our estimator will understand. And in this case, we did a grid search using a ridge regressor to find what would be a good alpha. Let me just redo this. I think usually with alpha we use log spaces. So let me just quickly rewrite this little bit of code. Import numpy as np. Good. So let's do np. So we'll actually, instead of a range, we'll do np log space -3 to 3. Let's do 10 different steps. So the different alphas we are dealing with then would be, let's just take a look at what they would look like. These are the different alphas we'll be dealing with. Okay. So let's fit this here, and let's see what happens. Or rather, our pipeline is set up. It might take a second to fit. And in the meantime, let's think about ways in which we could use spaCy to improve our model. One way that occurs to me is that when you're using a count vectorizer, it's often a common practice to remove stop words. Now, stop words are words that in a given language don't add much meaning to the text. So in English, that might be the or a. And if I go to sklearn count vectorizer, we can see that there is an argument for stop words. And in fact, scikit-learn comes with its own set of stop words. And so if I wanted to remove the stop words here, in my pipeline, I would just go stop words equals English. Now, this will be accessing a set of stop words that come from scikit-learn, but I could use the stop words that come from spaCy if I wanted to use spaCy. And if that were the case, I would do from spaCy lang.en import stop words. And here where it said stop words English, I could replace it just with stop words. So that's one example where spaCy might be helpful. I'm going to interrupt this kernel because I don't want to lose time. Although I do want to go verbose equals 1, and that way we can see it training. Let's actually just take this here and put the ridge directly in. And let's see what happens if we try to run it this way. Oh, wait, stop words is not defined. So I'm going to run this same pipeline. I'm not going to do a grid search. I'm going to do a count vectorizer, and I'm going to use stop words from spaCy before the count vectorizer works. So let's see what happens if I do my fit that way. And again, this will take a while because count vectorizers are notoriously slow. Now, Nana has an idea, which is we could use spaCy to divide each review into sentences. Let's see how this worked. So I have a 0.89, which is just below the threshold for 0.9 with my stop words. And I think that if I remove my stop words, I remember we tried this last week, and I think we actually got a better score by keeping the stop words in. Let's check it out. Let's see. Now, Nana has the idea that if my original review is, I love this computer. Let's say this is an example. It is really fast. The price is good too. Okay, we have our new pipeline working. And if we run it through the grader, we actually get 1.07. So we beat the model just without removing any stop words. So let's say that I have my test review equals, all right, this. Now, if I wanted to divide this into sentences, what I could do is simply split it on the period. So I would do dot split, and then I would mark the period as my argument. And so this would give me the 3 sentences in my review. So I don't necessarily need to use spaCy in order to divide these sentences. The reason I might want to use spaCy, so let's see here. Let's look at spaCy. So I might, if I was going to use spaCy, I might do NLP equals, well, let me import spaCy first. So I would do import spaCy. And I would do spaCy dot load en. Let me make sure this works. Great. And then what I could do is I could go, my document will now equal NLP test review. So if I look at doc, this is the language I have here. But what I could do is, or what spaCy does is it doesn't divide the text by the punctuation, but rather it's going to go through and parse the pieces, the grammatical components of the text. So, for example, if I wanted to look at all the nouns in my review, I might do something like chunk.text for chunk in doc.noun chunks. And so this would automatically pull out all of the different parts that pertain to noun chunks, Or if I wanted to look at verbs, for example, I could do something like token.lemma for token in doc. So this would show me everything. But if I wanted just verbs, I would go if token dot pause equals verb. Oh, token is not defined. Oh, excuse me. This should be an if, right? And so this would show me the 3 verbs that are used in the 3 sentences. So spaCy can do a lot of cool things to kind of answer Nana's question, but it may not be super useful in question 1. Are there any other questions about question 1 that I can answer before we move on? I hope that answers your question, Nana. Okay, now for question 2, what I'm doing is essentially the same thing that we did in question 1, but the difference is that instead of using a count vectorizer, I'm using a hashing vectorizer. And the great thing about a hashing vectorizer is it's a lot quicker to train. So if you were watching, you guys saw that this fit process took a lot less time than it did in question 1, and that's because I'm using a hashing vectorizer, not a count vectorizer. Tolulope says, thanks for the examples to explain spaCy. I'm glad that it was helpful. So now we are here on to question 3. And Tolulope said that they had some problems here because their model was basically dying on them. Let's see how we can maybe do this a little bit without having that problem. I think that for this particular problem, what I would like to use is something that we haven't used up until now, but it's mentioned a little bit earlier, and it's called TF-IDF vectorizer. And I'm not going to go over sort of how it works. I don't want to repeat what was already in the videos, but let's just look at an implementation of it here. So I'm going to grab this import code and paste it right here. And I think what we should do is just put together a basic pipeline with the TF-IDF vectorizer, and let's see how it works, and then we can always go back and tweak it. So if I want to put together a pipeline, what do you guys think that I should include in my pipeline? Enzo, just so you know, I see your question. And as soon as I answer question 3, I will address the one that you've just put into the chat window. Until then, though, what do you guys think I should be putting in my pipeline here? Oh, sorry, I had my sound off. But you guys were doing such a good job giving me the answers that I just got kind of lost in thought. So I have my key selector, and I'm looking at the review text. And then I add my TF-IDF vectorizer. And then I'll add my regressor, which we'll say in this case is ridge. So I'll do my ridge regressor, RGR, and I'll say that this is ridge. Okay, so that is that. And then I can just copy and paste. Well, I can just do my bigram model dot fit. And let's see here, it would be data and ratings. Let's fit this. You can see how quick TF-IDF fits, which is like very nice in this case. And let's see how my model looks in terms of the score I get from the grader. So my score is 0.99, which is pretty darn good. Let's think of ways that we can improve it that are relevant to this question. So here we've been looking at, here this question is interested in bigrams. And so if I go to TF-IDF vectorizer, yep, I can look at the, here we go, n-gram range. So that's the hyperparameter that I'm interested in looking at. So I would have my hyperparameter n-gram range. And usually you give it in the form of a tuple. So you say 1 to 2. Let's just take a quick look at this and make sure that that is right. Yes, so the minimum and the maximum. And note that this is actually, the maximum is actually inclusive in this case. So it's a little bit different than the standard in Python. It's inclusive. So now I'm adding bigrams just by adding this 2 here. If I added a 3, I would have bigrams and trigrams. Enzo has a great idea about using a hashing vectorizer. Let's try all these different combinations and see what happens. So let's just start with the n-gram range. Let's see how this model does. It's going to take a little bit longer to fit because it needs to create all those n-grams. Looks like my kernel died. Is that what's happening to you, Tulalupe? Is it just dying? Let's try one more time, and then if it's not working, let's think of some workarounds so that we don't get stuck in despair. So let's open everything up again. We have our ratings. We have our key selector. Tolulupe says this is the bigram curse. Curse you, bigrams! Let's try one more time, and if it doesn't work, we will try something else. I am sort of surprised. I would think that this is not a very heavy computation, but we'll find out. So far, so good. Everyone keep their fingers crossed. It looks like my kernel died again. I am really surprised about this. So let's do the following. If our kernels keep dying, maybe what we're doing is we're passing in too much data. So let's see here. How can we make this a little bit lighter? Well, one thing that we could do is we could remove stop words. So there would be basically less data to crunch. So I'll take question 3 and I'll add stop words equals English. Or did Tolalupe, did you try this and it didn't work? Let me rerun the cells that I need to rerun here. Okay, let's see if this works. And if not, I have an idea. Everyone hold your breath. Don't move. Okay, so we removed the stop words, and that looks like it made it just easy enough to get it done. So let's see how the fit worked. So it looks like we had some success by removing the stop words, and we even improved the model a little bit. Now, keep in mind that I did stop words in 2 different ways here. In the first example, I imported the stop words from spaCy. And in the second example, I said, I'll just use the stop words that come in scikit-learn. And I believe with the latest version of scikit-learn, it's easier. You can sometimes get error warnings, or it'll throw errors if you're using a different stop words from a different library. So while I don't think it makes a big difference here, this would be my recommendation, is stick with the stop words that come in scikit-learn. Now let's go to Enzo's question, or Enzo's proposal, which is using a hashing vectorizer instead of using a TF-IDF vectorizer. So I'll remove this, or rather, I'll just turn this into, let me make sure I've imported everything. Oh, let me import my hashing vectorizer. Hashing vectorizer, and let's just make sure the arguments are the same. N-gram range and stop words. Okay, let's see what happens when we do it this way. Nope, my kernel died. It's a little temperamental, huh? One thing that I could do if I wanted to make this a little bit of a lighter lift for my virtual machine, so let's say I'm having this issue and I want to go, how can I get this through here without my computer dying on me? There are a few things I could do. With the hashing vectorizer, there is n features. So n features is the number of columns that are going to be in the output matrix. So with a count vectorizer, each word gets its own feature, but in the hash vectorizer, these words are hashed. And so you're not actually looking at the representation of the word, but you're looking at a sort of transformed version of the word. And so that's the reason it's faster, is because they're basically less features after all. But what I could maybe do here is limit the number of features to, instead of, I think the default is 2 to the 20th, let's try 2 to the 10th, 2 to the 10th power, and see if that makes it, oh, let's see, I forgot a comma. Let's see if that makes it doable. All right, so this was able to train. And if I run it through the grader, sometimes it takes a few tries. Well, my model is a lot worse. It performs a lot worse, but it does actually work. So that's a plus. And if I increase the number of features, so basically what's happening is when I decrease this number of features from 2 to the 20th to 2 to the 10th, I'm underfitting. My model is underfitting. So that's why my score is so low. And if I turn it to 2 to the 15th, and if it doesn't crash, this should improve it because it should fit better. So let's see if I can improve on my 0.43 score. And now I'm up to 0.83, just because I increased the number of features from 2 to the 10th to 2 to the 15th. So there are lots of ways to put these pipelines together. And the cool thing about pipelines is that it allows you to sort of swap out the different components. Another thing that I could do before we move on to question 4, or the other question that Enzo had, is if I go to train test split, maybe if I just reduce the amount of data that I'm passing through my model during the fitting stage, I don't have to worry about it dying on me. So if I turn this back into a TF-IDF vectorizer, and before I run my data through the fit, what if I did X train, Y train, X test, Y test equals train test split data ratings, and then what the other argument I need to include is test size. So test size, and let's say I hold almost a third of the data back. So now I'm only training on 2/3 of the data. So here I would do my X train, Y train. This gives me an error. I wonder what this is. Float argument must be a string or a number, not a dictionary. I wonder why it's throwing me that error. That is very strange. Let me look at the type of X-train. It's a list, and data, is data also a list? Also a list. Data shape. Oh no, wait, hold on. What? Excuse me, it's a bunch of dictionaries. Well, I'm not quite sure why this is not working. It should work. So let's go data length 8,000. And then if I do X train, it's 56,000. And if I look at, it's the same thing. Maybe it's my Y train. Also a list. The length should be 24,000. That's odd. Hold on. 56,000. Well, that's the problem. I think what I did is I X train, X test. Oh, I know what I did. I put the problem is that the way I should have done the train test split variables is it's X-train, X-test, Y-train, Y-test, and I had it X-train, Y-train, X-test, Y-test. So I was actually mixing up the labels and the data. So here we go. Let's try this again. I guess it's why documentation is such a wonderful thing. So now X-train is still 56, and then Y-train should be the same 56. Okay. So I'm now training on 2/3 of the data. And my kernel died. I can't believe it. It's so sad. There's been a lot of death in today's office hours. I'm sorry you guys have to witness it. Okay. Nana's like, please, can we move on? I don't blame you. Let's hold back even more. Let's hold back half the data. Okay, and this was able to train. And if I run it through the grader, I still get 0.96, even if I train on only half the data. So I guess what we've seen is we've seen a few strategies, just to summarize. If you're having trouble getting everything through your pipeline without your computer crashing, the one thing is you might think about reducing the load on the computer. So either if you're using a hashing vectorizer, you would limit the number of features. If you're using a TF-IDF vectorizer, you be sure to remove the stop words, especially if you're using n-grams to reduce the number of features. And then a strategy that would work on either type, TF-IDF or hashing vectorizer, is only train on part of the data, in this case, half the data. So those are a few strategies that you can deal with or employ. So just to quickly answer Enzo's question, they ask, is there a way to change the kind of bootstrapping that the random forest classifier uses? Because they, instead of just doing straightforward bootstrapping, want to do something called sequential bootstrapping. So let's check out the bootstrap argument. It looks like there's not a way to change the type of bootstrap. And I'm wondering, and this is me thinking out loud, Enzo, I'm not sure, but if every tree, if we're doing a random forest and every tree is supposed to be independent, would we want to have bootstrapping that depends on previous, the way it worked in previous trees, or do we want to keep all of them independent? Is maybe what you're thinking, it would make sense to do something like a gradient boosting tree. Would that get you the same effect? So I guess the short answer to your question is I actually don't know, but I'm curious as to why you would want to do it that way, or whether it would be sort of a significant difference. Again, I guess I have more questions than answers on that particular question. Okay, what else would you guys like to look at? We have 10 minutes left. What would you like to do with that time? Tulalupe would like to do question 4. And I think we can definitely dive into question 4 with the time we have left. So let's get this new data. Where are we? And now that everything is downloaded, I'll delete the old data we were working with to avoid issues. And for ratings, we'll want to do what we did earlier in the notebook. Where are the ratings? How did we do that? Here we go. So we can redo the ratings. And it won't be data that we're looking for, but rather data polarity. And let's just make sure that we have what we need. Okay, great. So now what we need to do is we need to put together a pipeline, and it needs a bunch of different things. It needs, well, what do you guys think it needs? So I'll call it pipe equals pipeline. What should I put in my pipeline? So I'll put in my custom selector first, which in this case, and I'm working off of Tulalupe's answer. So I have my selector, and in this case, it's going to be our good friend, the key selector, and we'll be focusing on the review text. And then what comes next? I love it, Corazon. Let's put in our TF-IDF. So we'll put in our vectorizer. And in this case, we'll go with TF-IDF. So TF-IDF. Stop words, we'll say English. Okay. And then what's the final piece? I need to add my estimator. Tulupe is correct. So in this case, since this is a classification problem, I'll call it a classifier. Corazon is absolutely right. We're adding our multinomial naive Bayes. So, okay. And then I will do pipe fit data polarity as my X, and then the ratings as my Y. So let's see if this works. And oh, that was super quick, huh? I love naive Bayes. Beautiful. And so I've now trained my model. So I'm now have my model. And if I look up at the instructions, I want to access the log probabilities, the feature log probabilities. So how would I do that? Dead kernel. Dun dun dun. I guess I was lucky that it got through my kernel. My advice is if you're having trouble with the dead kernel, use some of the techniques that we discussed. For example, only training on some of the data. So if I want to look at particular parts of the data, for example, the feature log probabilities, I could go name steps, and then that would help me get to the classifier. And once I was at the classifier, I could use the feature log probability attribute, and that would give me an array. Let's check out the shape of that array. And so here's my array. And this is the beginning of how I would begin to solve this particular problem. Okay, I'm going to stop sharing my screen. I do see one last question from Enzo, and I'll end office hours on that. And Enzo says that they're trying to implement sequential bootstrapping following a model proposed by Marco Lopez de Prado, who recommends editing the class in order to replace standard bootstrapping with sequential bootstrapping. Well, I mean, certainly that is definitely something that you can do. I would say that changing classifiers is a little bit beyond the scope of this course, but I would suspect that Marco Lopez himself might have some sort of implementation, like if he has a GitHub page, it might be on there, and you could actually just take that class from him instead of building it yourself from scratch. So I would do a little bit more investigation and see if somebody has already implemented the solution so that you don't need to do too much coding from the ground up. Okay, everyone. I'm glad we got to have a start on question 4. I'm glad we got to look at question 3. And for now, I will say adieu, and I will see everyone tomorrow. If you have questions before then, please post them in the forum. And I will see you all later. And I hope you all have happy machine learning lives until then. Take care. Bye.